I think you did that well, except for you put an H in my name. I guess if I had a dime for each H that has been mentioned in my name over the course of my lifetime, I would have that yacht sailing in the Caribbean. But it's such a pleasure to be here with you today to talk about how semantic search is helping scientific researchers to be more effective and more efficient now, not tomorrow, but now. Okay, what are some of the challenges that we have in scientific research? We're going to talk about that. I'm going to give you a brief one-slide overview of the Colexis technology. I'm going to show you some case studies from professional networks that Colexis has developed. We're going to talk about some institutional networks that we've developed for various different institutions, specifically Johns Hopkins. And also my good friends at Pier 39, James Oppenheim, he let me borrow some slides to show you what they're doing with semantic advertising. Well, how many of you have heard of Project 10X? Raise your hands. Oh my goodness, this report has been out since 2008. Mills Davis, he has an excellent executive summary. He's going to kill me when I tell him tomorrow that I said that executive summary is great. You don't need to buy the whole paper because he charges like $4,000 for it. But really, this is a must read. Very well done, very well done. Well, he talks about the web in 4 stages. And right now, we're in what he calls Web 3.0, which is the semantic web. Well, Web 4.0, that's the ubiquitous web. That's a ways off. But when we think about the semantic web, you know, you have your operating system. Of course, there's the internet. And then there's the knowledge plane. And the knowledge plane is where we really start to allow folks to do knowledge discovery. And then as you see the development path of the semantic web, you see that here, we are very close by the thesaurus line because as we heard today, a lot of folks are trying to understand what's the difference between an ontology, a taxonomy, a thesaurus. Well, those are tools that allow us to enrich our algorithms. Well, here's the Colexis technology, very simple. We're able to take structured data, unstructured data, and we have a knowledge base that consists of 19 algorithms, which are proprietary, along with a subject-based taxonomies, such as we use mesh. And what we're able to do is to take any data, we're able to aggregate it into key concepts. Now, these concepts are not based upon frequency. They're based upon relevancy, the meaning of a word to another word in a sentence, in a paragraph, in a document, in a book. And then from there, we're able to further refine it. And then we're able to create what we call a radio dial, which you can then manually adjust the algorithm to your needs. So if you wanted to say, no, I don't want to talk about Iraq, you can make that term obsolete, or you can add in other terms as well. And the beautiful thing is we're able to translate this into other languages. We could translate it into Mandarin, we could translate it into French, Chinese, whatever, Spanish, whatever language that you prefer. Just a few of Colexis customers so that to show that Colexis has blue chip technology and it has blue chip customers as well. Now this is the one that I love. This is the one, now it's interesting, I used to work at Elsevier. I ran their Americas, I launched Science Direct Scopus. I was there for 11 years. I left and went to Colexis. And I used to take one of their examples from Science Direct, which is Alzheimer's, and I would say if you put a search into Science Direct, you're going to get a result set of 20,481 articles. Now, who's going to read all of those abstracts? No one. So how do you extract knowledge out of that? Well, what we're able to do is to merely create a digital fingerprint of those 20,000 articles. So immediately a researcher can see the concepts that they're working on. They can see concepts that maybe were top of mind but not at the front of their mind. They can see concepts that maybe they hadn't thought about. And then from there they can dive into those concepts to see where those articles, those concepts were derived from. And you get the timeline of the articles as well. So you can see what's going on with Alzheimer's research over a 10-year period. Again, from these digital fingerprints, there's a host of things that we're able to do. One is that we're able to create expert profiles. Now, talking about solving a simple problem, when Colexis was acquired by another investor and they brought in new management in 2006, one thing they realized, it's hard to create to really compete against a Temis. It's hard to compete against an autonomy. So what specifically should we do that's going to make us different in the marketplace? And we said, you know what? We need to solve problems. We need to create applications that people can use right now. And we're going to talk about that in a second. But what we did do right away was that we launched biomedexperts.com. Biomedexperts.com is the world's first pre-populated professional network for life science researchers. Basically what we did, we meta-mapped PubMed. We're able to extract all of the author information and articles out of PubMed and create a social network. So we can show you who is the expert in diabetes by a particular concept. We can show you who their co-authors are. We can show you their record of reference over the last 10 years. And immediately when an author goes to a profile, they see that their profile is 100% accurate. Now I heard one gentleman talk earlier, I guess he was the first gentleman who did the 5-minute presentation, how their algorithm goes up to 80%. And our algorithm actually goes up to 80% as well. The other 20%, say the rest of the tail, we allow the author to determine if particular articles are part of their research, and there's a real simple wizard that allows them to control that. So they immediately see their profile, they see there are more than 24 million co-author connections, and these are representing over 3,500 institutions from over 190 countries around the world. And today, this database has over 300,000 registered users. And here is a fingerprint of a particular author's profile. So immediately, you can say, who is the expert in diabetes? Let me look at their concepts that they are researching. And then, of course, you can see their publications, their co-authors, their network view, and geo-network view, as well as times and places. Now, the cool thing about this, one thing that we realized, was that we were having a number of consumers to go to the site to find out who is the expert in a particular disease category that I may want to connect with. And here you see the co-author network, where the author is in the middle, his co-authors is the first circle, the second circle, and the third circle is the co-authors of the co-authors. The cool thing about this is that what we've determined is that the 6 degrees of separation is actually 3.4 in scientific research. And then if you're traveling, you're a researcher, you're traveling, let's say to Australia, you want to see, well, who is in my network in Australia that I might want to have coffee or dinner with? We can immediately show you who your connections are. And then you can look at their profile, send them a message, say, hey, I'm going to be in Australia, love to have coffee with you, talk about a new project. That saves a researcher time. And we did the same thing for American Institute of Physics. Have any folks gone on to AIP Unify? It's a great site. It's free. We have profiled more than 180,000 physicists. And there we've added other features as well, which you can see someone's CV. You can see not only their research profile, but the research profile of people inside and outside of their network. Now, at Johns Hopkins, back in 2006, they had a particular issue. The issue was that they had several researchers who didn't know each other. They had people sitting right next door to each other who didn't know each other. So they had a fall retreat, and during that fall retreat, they talked about this problem and how could they solve this problem. Now, the overwhelming answer was, we need to collaborate more, we need to interact more, we need to socialize more. So they said, let's build a coffee shop. So what they did, they actually took a part of the parking lot and they built a coffee shop. So a year later, they came back and they asked, so how is it going? Someone said, hey, you get great coffee. I've met a couple people, but we still have the problem. And that's when they called in Colexis to say, hey, how can you solve this problem? Now, Colexis at the time was trying to sell them what we called Knowledge Dashboard. And this is where when you're a startup company, and Colexis, while we have been around for a number of years, we consider ourselves a startup. You know, you have to think about how you're going to satisfy that problem. So we were trying to sell them a knowledge dashboard about a disease category such as Alzheimer's or diabetes. And they said, you know, within that dashboard, you got these expert profiles. And that's what we really want. So we said, okay. So we came back with a couple of templates. They said, yep, this is exactly what we want, but you need to add this and add that. Next thing you know, we had an application called the Expert Profiles that really put Colexis on the map. And the rest is history, because The end of the story was that I actually went back to Elsevier and said, hey, this company I left you guys for, this technology is really cool. You should acquire them, which they did in June of this year. So what the expert profiles allows the Johns Hopkins audience to do is to connect with each other in regards to who is doing research in a very, very particular area of science that I'm working on. Johns Hopkins also led the way in putting their institutional dashboard up on the web for the public to see. And the reason is that they want people to know about the expertise within Johns Hopkins and being able to identify with who the experts are. Secondly, the people who are in their area of donation and gifts said, we want to promote this to the people who donate money to Johns Hopkins because we want to demonstrate to them that we're providing value back to the community. And their site, it gets a lot of hits, and it has been a really big hit for them. And other institutions, such as the Mayo Clinic, have also followed them in this regard as well. So here you see, this is a profile of a particular researcher. And if you notice up here to the top, we give you a snapshot of their profile. We give you a list of their recent publications. We show you some similar experts. We tell you what journals they primarily publish in. And then we're able to show you some trending information. And if you were to click on that box that says trends, it blows up to a nice chart where it shows you the different subject categories of research that they're doing. And it allows you to dive right into that area to see exactly the article that they wrote in that particular subject. Gives them a lot of information that they normally would not have if they would go to PubMed. Because everyone says, this data came from PubMed. Why would someone pay 6 figures for this? And they pay 6 figures because it solves a problem, it gives them access to information they need right away, and it saves them a lot of time. Ultimately, makes them more effective. Now, this is really cool. This is the map that we show them in regards to their internal experts and their external experts. We got the researcher who's profiled with the red dot, and the internal collaborators are the people in the purple dots, and then the external collaborators are the smaller dots. Now, the cool thing about this, if I was to show you a live demonstration, you would be able to see the profiles of each of those folks. The same information, and then you can start the whole process over again. So again, it's taking some very, very extract information, but making it very pointed and very much easy to access. Let's talk about Asclepios. Who has heard of Asclepios Hospital System in Germany? 2 people. Okay, great. Asclepios Hospital System has grown organically through acquisition. They actually service over 500,000 patients in 95 hospitals with 21,000 beds. They have 34,000 employees. Now, they also own a medical, nursing, and allied health school, and they have home care programs as well as residential programs. Now, they do have some sites overseas. Here in the United States, they got Pacific Health System. In Greece, they got the Athens Medical Center. And then they also have a university hospital in Shanghai. They had a fundamental problem. How do we know what we know? There's so much research within Asclepios. We want to know what we want to know. So what is the process that we're going to utilize so that we can find out who are the experts within our area? Well, number one is that they set up the guided workflows, and then they wanted to optimize the workflows by making sure that folks could get access to information without taking them out of their day-to-day activities. They didn't want them to have to leave the bedside of the patient to go to the terminal to try to find information. They wanted to make sure that they're able to distribute this expert knowledge to all of their researchers across the system because they're all over Germany. 2, they wanted to stimulate a new acquisition model. They wanted to encourage a new behavior for the doctor so that when the doctor's at the bedside, that they wouldn't be opposed to using their terminal to get information that a patient might ask about. Because if you saw the doctors at Asclepios, they actually have a mobile sterile unit, which is a wireless device that they carry around to the patient's bedside. So if we take a look at Asclepios, they're in Germany. You see all the locations there. And if you're trying to find a very particular doctor, in this case, Dr. Grifka, who is in orthopedics or rheumatology, how could you find him without having this type of knowledge base? It would take a lot of phone calls. It would take a lot of referrals. Here, you can immediately put in, I have a particular problem with this particular patient. who's the expert within Asclepios, and it will provide you that information. Immediately, you get the nice picture of Dr. Griffith. You say, it looks like a pretty friendly guy. I'll give him a call. You see his profile, and you see his recent publications. These three key data points are very important for a doctor to pick up the phone and say, Dr. Grifka, I have a patient who has a particular knee problem. I'd like to get your opinion about it, or I'd like for you to help me with this patient. Secondly, what they were able to do, they were able to take data from Springer, Elsevier, Teaming, Ovid, and other publishers and aggregate it in all in one database. I mean, Elsevier has Science Direct. Wiley has IntraScience. Steamy has their own platform. Every publisher has their own platform. Well, for a researcher, that's too many clicks. Everyone wants ease of use, but we want to click into context, which is so important. And with their system, utilizing the Colexis technology, they're able to go from opening a journal article, which will show immediately similar publications in their colleagues, and then the names and the expert profiles of those colleagues. So they're getting information and context in real time. Now, I'm going to change gears here. I'm going to talk about my colleagues at Peer 39. Some folks are familiar with Peer 39, semantic advertising. No? There's one hand, two hands, three hands. Okay, good people. They got some exciting things going on. But their semantic advertising solution, and what they're able to do is that they're able to allow advertisers to target ads based upon what someone is searching on the web. So to give you an example, if you look at, you got the Amazon is a great place to visit versus Amazon is a great site to visit. They're able to distinguish between the two. Also, they're able to distinguish between Dolly Parton the entertainer and Dolly the sheep as well. Jaguar the car versus Jaguar the singer versus Jaguar the animal. And what that allows them then to do is to take all of these categories and then precisely pinpoint then ads into the right place. So you see all these different categories that they have. It gives you a transparent and actionable results in real time. It's flexible, it's easily mapped. They can categorize it to your customization that you want. It's highly granularized categories and keyword overlays. And so what they do is they provide a actionable classification data across the advertising ecosystem. They support over 30 billion ads per month, and it reaches more than 300 million high-quality uniques. And it targets a growing universe of hundreds of publishers. So basically what they're able to do, that inventory that you have, instead of doing the run of site, they're able to really maximize those particular pages that are not being used or not being advertised and place them with the right type of ads. So in summation, semantic technology will allow you to aggregate large amounts of structured or unstructured data. It does allow you to boil the ocean. Now, I will say that with a caveat that it depends upon which area of the ocean that you're trying to boil. Because what we learned at Colexis was that we wanted to make sure that we started with the life sciences, and then we went into physics, and we know that it would work in other areas as well. Matter of fact, later on this month, we're going to launch at the University of North Carolina, where we have profiled all 15,000 of the researchers in the state of North Carolina across all subject areas. And that's where we've married the Colexis technology with the Scopus database. So we know it's possible, and we're very excited about that launch. But again, when you go into other areas, it's not a panacea. You have to go in with baby steps and make sure that you understand your subject area. It allows you to identify the key concepts of the data set, relevance versus frequency, and that's very important because the last thing you want an author or a user is to have a false response to one of their searches, because they'll be disappointed, and it's almost like you go to a store and it's closed and you go down the block to another store and you never go back to the other store. So you want to make sure that you have that covered. You want to organize and visualize the key concepts to provide a macro view. Whoever you are, semantic technology, find yourself a great GUI guy. We got a GUI guy in Germany, and he is the guy who makes it happen because he takes that abstract looking information and he makes it look very good. He makes it practical, very important. Ability to search large corpus data utilizing the key concepts. You can use it for advertising, putting the contacts and content, placing relevant ads in context, utilizing your inventory more precisely. Ultimately, semantic technology will help your user community be more efficient and more effective. And at the end of the day, let me tell you, I've been in this marketplace a long time. Dow Jones 13 years, Elsevier 11, Colexis now 3 and working on something else. It's about reducing clicks. At the end of the day, it's about reducing clicks and putting information in context. Thank you for your time.